All right, this is the final question. This is 3D from the 20. I just want to make a smudge across the page then. Sorry, it's just. Oh dear, getting to the end here. Okay, show that the roots of the equation blah, nasty looking sucker, isn't it? Where k is a constant and can never be equal for any real number of k. Sorry, I'm just still laughing at the previous thing. Okay, so all right, so to do this then, what we should do is we should find the discriminant of this thing here. And what we're going to try and do is to see if this is going to result in a value of k that is going to be less than 0. And that's what we're looking for. Is that going to be true? So let's take a look. So what have we got? We've got, okay, so I'm going to restate the question. I think it needs restating. X squared, I've got a plus 2k plus 1 x minus, and this is k squared plus 2k plus 5 is 0 is what it reads. And this is not very useful because the coefficient of x, of course, is the whole of that. So let's restate. This is going to be x squared plus 2k plus 2x. That's really what it should be. And this thing here is actually the entire thing. So I'm going to go plus, and then we're going to have minus k squared minus 2k minus 5 is 0. That's the form you wanted in, because the coefficients of x squared, x to the 1, and x to the 0 must be positive. These must be stated positively. So, so A, therefore, is the positive 1, which is in front of here. B is this one here, which is 2k plus 2. And C is this thing here. It's positive, but the contents of it are all negative. K minus 2k minus 5. So when we come to the discriminant, which is b squared minus 4ac, and we're going to test this really to see, does this equal 0, yeah? So, okay, where do we end up? That's what we're asking. Okay, so b squared, that's going to be, that implies we've got a 2k plus 2, all squared 2k plus 2, minus 4 times a, which is 1, times c, which is negative k squared minus 2k minus 5. All right, let's expand all this out and simplify. We've got 2k, it's going to be 4k squared plus 4, and then we've got a 4k, and another 4k is plus 8k. This is all minus 4 times negative k squared minus 2k minus 5. So I'm going to expand all this out. So we're going to end up with, that equals 0, equals 0. So this is going to be, implies that we've got a 4k squared plus 8k plus 4 minus 4k. It's going to be plus 4k squared minus 4k times minus 2k is going to be plus 8k. And minus 4 times minus 5 is going to be plus 20 is equal to 0. Let's collect like terms. So I've got a 4k and a 4k is going to be an 8k squared. There it is. Oh, wait, there. Sorry, my bad. I'll cross these out the other way. That one and that one is going to be plus 16k. There it is. Then I've got a 4 and a 20 is going to be plus 24 is equal to 0. Let's divide everything by 8. Divide all of that by, in fact, divide everything by 8. You wouldn't write it like that. That's just ridiculous. Not good. Divide that by 8 and divide this by 8. So that's going to be an k squared plus 2k plus 3 is equal to 0. All right, so that would be 3 times 1. Well, that doesn't factorize. You're going to have to. You could use the quadratic equation for that, but just as easy to go ahead and say, let's use the discriminant, yeah? So we've got k as a value of 1, so a is 1, b is a value of 2, and c is a value of 3. So this is going to be a little bit awkward. What's that going to be? So we've got b squared, which is going to be 2 squared, minus 4 times a times c. And what does that come to? Let's have a look. That's going to be 4 minus 4 threes are 12, and that doesn't equal 0. It doesn't equal 0. It's less than 0. It's a negative 8 is less than 0. Therefore, yeah, it doesn't equal 0. If it did, we'd be in sitting pretty, but it doesn't. Therefore, there are no real solutions. So we'd have to say that K, actually I'm looking at what they've actually got in their answer actually. So they said there are, no, hence the values of K for which the original equation has no real roots. Yeah, so that's a good way of putting it. Let's go with what they've got. So therefore there are, I hate going to the actual solution because I like what I say better, but there are no values for K for which the original solution has equal roots. For the original equation for what am I for? For which I should put for which the original equation has equal roots. And that's how I would do that. So yeah, so I would say that's the I like what they've got there. Actually, it's a good way of expressing it. It's a very messy thing to do. We were hoping it would equal 0. It really doesn't. But because it doesn't, there are no values of K that makes it the original equation have those equal roots. So that's what we found, and hopefully that makes sense. A bit of a messy one to finish with. Yeah, I probably would have done that differently in hindsight, but hopefully it makes sense.